Hey, today I'm going to show you how to do this limit right here. So clearly direct substitution doesn't work because we get kind of a 0 over 0 function here. But the good news about limits where direct substitution yields a 0 out of 0 is that they can actually be really easily solved by factoring. Okay, so trying again. This time we're going to go ahead and deal with each one separately and we'll factor them one by one. So as you can see, we can rewrite x to the fourth minus 16 as a difference of two squares, x squared squared minus 4 squared. So let's remember the difference of two squares formula here. A squared minus b squared equals a plus b times a minus b, and apply it to this, where a is x squared and b is 4. And voila, we get that. But the funny thing is that x squared minus 4 is also a difference of two squares, so let's look at that. As you can see, we have x plus 2 times x minus 2 as the difference of two squared simplification of x squared minus 4. And so replacing that with our initial x squared minus 4, we get this factorized version of the statement. So now we're going to go ahead and take a look at x cubed minus 8 and factor that and see if there's anything we can reduce out to solve this limit. In this case, x cubed minus 8 is a difference of two cubes, so let's look at that. So remember the difference of two cubes. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So we can, of course, translate that to this, where a equals x and b equals 2. And then, simply put, we get this statement. So let's move on to a different flashcard and kind of rearrange all this. So, starting back with our limit, remembering that these are the factored forms of these two expressions, we substitute those in and we get this limit. Okay, so now we get this thing, and would you look at that, we actually do have some reducible terms here. Our x minus 2's work. Don't mind the difference in light. I finally remembered to turn my desk lamp on. Let's just reduce these out and see what we end up with. And we have a different looking limit now. So we can actually try out our direct substitution on this now. So now we do direct substitution, and we get 8/3. So the limit as x approaches 2 of x to the fourth minus 16 over x cubed minus 8 equals 8/3. Remember that because we're dealing with a limit, extraneous solutions aren't really an issue because we're only dealing with function behavior as it approaches a set value, and we're not worried about the actual solution point, which of course doesn't exist at x equals 2 for this function, which is why we could get away with reducing terms and not worrying about extraneous solutions. So remember, just because direct substitution doesn't work does not mean that you always need to use L'Hopital's rule every time. Especially if direct substitution yields 0 over 0, factoring will usually work in that case. So yeah.